Okay, so we move to another remote talk, which will be presented by Jacopo Tagliabue, and it is for the paper entitled "You Do Not Need a Bigger Boat: Recommendations at a Reasonable Scale in a Mostly Serverless and OpenStack." Jacopo, hello. Whenever you're ready, the floor is yours.
Ciao. As long as I see my slides, I can start. Also, very good pronunciation of my last name, of course, which is very hard for most people, but not for you, I guess, for obvious reasons. Hi, guys. I'm Jacopo from Coveo, and today we're going to talk about AI at reasonable scale. Let me see. The clicker works. Awesome. What is AI at reasonable scale? Well, let's start seeing what is not a reasonable scale. So this is a graph depicting the number of publications in 2020, but it's probably this year is going to be the same. In some elite conferences, in e-commerce tracks, which is most of what we do. There's one weird one, but then if you look at all the others, they are large public B2C company. They have humongous user base and basically unlimited money. Why is that? It is an issue. Well, it's an issue because it's find out that most of our AI and ML research agenda as a field is set by problems that basically 10, 15, 20 companies have, which are problems that are in no way representative of what the bulk of the market actually has. And especially with ML becoming more ubiquitous and smaller firm and smaller startup getting into the ML train, it's kind of like we're all trying to learn how to play tennis, but the only thing that we discuss is what Roger Federer is doing for training, which is inspirational, is awesome. I really like Roger Federer, but what he's doing is not really relevant to me trying to improve, my backend. So why is that the case? Like, why very few companies that are not humongous B2C company are actually contributing to cutting-edge ML research? There's a bunch of factors, and we kind of highlight here 4 of them. One is engineering, as in it's very hard to deploy complex models if you're not, like a very sophisticated big player. It's very expensive to do ML these days. So, some of the companies in the previous slide actually own a cloud provider, which is very different from people that have to pay cloud providers. There's, of course, a shortage of talent, as, of course, big data companies can attract the most talented engineers because they can pay, much more than other companies. And finally, there's a scientific challenges, which is, even when you read the literature, most of the models and most of the data sets that are present in the literature as much as a YouTube recommender system is awesome, the chances that the same recommender that works for YouTube works for a site making $100 million online, it's kind of like very unlikely. So we cannot solve all these problems at once today. We have 12 minutes, so we're not trying to do this. What the only thing we try to do is kind of like solve the first one. And in particular, today we're going to talk on how you guys can deploy complex models even if you're not a humongous company. So what is the reasonable scale more precisely? Reasonable scale is like jets, so it's very hard to define it, but you kind of know it when you see it. You can take of these 4 metrics as give you like a proxy for this area. So reasonable scale, we have some computing budget that we need to kind of respect. We can we make hundreds of millions of dollars, but not billions. And finally, we have quite some reasonable data. We have enough to make like a thing. We are not really swimming in data. If you want an e-commerce example, again, which is mostly my field, you can think of the difference between Coveo and Amazon, like companies that we saw in the first slide publishing in papers. Of course, we're very different companies. One is on a reasonable scale and the other is a reasonable scale. And the question is like, how can we bring more reasonable scale companies to be part of this community? So how did we end up here? We all know that, how the field gets kind of like, gets very, very popular in the last 10 years. So some of the bigger players start open sourcing, frameworks and, ideas on how to democratize statistical learnings. Everybody as a field get really excited and started applying ML to a lot of use cases. So even smaller company And while there's a ranging debate on the perils and opportunities of AI, this, by the way, are awesome books if you're interested. The reality is that outside of big tech, ML is not as flashy as you see, and the recommendations are very, very hard to put in production. As they, meaning Google, Facebook, and so on, figure out how to get value out of the ML system, but most of the people actually didn't. So this is where we are now. As in, if you go outside, like a very restricted number of companies, it's very hard to you to find, cutting edge ML put in production. So the reasonable scale is characterized then by constraints and limits. Constraints comes in terms of what you cannot do, as in, of course, you can't hire all the people you dream of, you can spend all the money you want on computing, but it also comes in terms of limits, which is your business is typically not a global business, meaning at least from day one, if you're a small startup or a more traditional business, your digital offering will not need to serve $2 billion customers like Facebook. And this is good. Of course, constraints make your job harder as you don't have all the resources that other people have, but limits make your job easier, as in, since you don't really need to serve the planet, you can kind of use a lot of off-the-shelf solutions to make that work. So one of the problems we see, and I think this is slowing down adoption of ML across the entire market, not just the big players, is that there's not much clarity on what are best practices and actually what is a tool chain that works for reasonable scale companies. For us, based on dozens and dozens of deployments, we kind of single out three principles. The first one is most important, is data is king. As in, the most important thing is data quality, and the marginal gain in improving your data is much bigger than tweaking architecture. This again goes back to smaller company for which a small architecture tweak doesn't really matter. It's not like Amazon where 0.1% click-through rate improvement translates into billions of dollars. For smaller company, architectural improvements are way, way, way less important. The second principle is passive better than yes. That is, since your resources are scarce, you cannot hire everybody you want. You should focus on what's your core problem, whatever that is, let's say a recommender system, and buy everything else, especially buy infrastructure when there's no high value in actually owning that. And finally, while big data has been a huge part of the Spark and big data system has been a huge part of the current data science landscape, today, thanks to smart data storage, modern laptops, easy access to scalable computing, actually distributed computing is way less important than it used to be. And distributed computing introduces a lot of complexity, and if you really don't have to do it, our suggestion is you really not do it. So all this is principles and words. What does it mean to build a company at reasonable scale? Together with this paper, we release a full open source implementation of a full stack, meaning that if you go online and check the repo, you're gonna find out a code that gets you from raw data, like millions and millions of real data, to an actual endpoint serving a recommender system. Which is the recommender system we're serving is the one from this paper, from the literature called Bear Go Shopping, and is basically a transformer-based model for session-based recommendation. So it may not be the cutting-edge model, but it's surely a very recent and very complex model by most standards. And what we do is we show you how to go from raw data that you may ingest to a normal beacon to how you actually serve this literature model with basically doing no infrastructure or maintenance work yourself. And all the code is open for you to try it out. So what is the problem? The problem, we all know it, is giving a shopper browsing on a website, she's interacting with a bunch of items, and the question is what she's going to do next. And so we need to train a model taking into account an history of session and feeding into the model, train the model, and then deploy the model so that when faced with a new session, the model is going to be able to suggest a new item. Of course, there are already a lot of code and things online that kind of tackles into pipeline and tooling. And the question is why you guys build a new one? Well, in our experience, most of what you find online is you then tend to focus on one tool or one step of a time of a machine learning pipeline. And so kind of leaving you to wonder how the rest works. And on the second side, they tend to work with toy word fashion, as in, with small data set or things that are not really realistic. On our side, what we do, we provide an open source code that goes from raw data to deploy infrastructure with all the things in the middle, and we run the pipeline under realistic load. What we do, we leverage a huge open data set that we released last year, containing millions and millions of real shopping events, anonymized, of course. And so we run the pipeline and what is realistic load for a releasable company. So if you're interested, this is actually what our suggested toolchain looks like. It's not about the tools per se, as we can always sit down and disagree over prefect versus Airflow or whatever you want to do. It's more about how you break down a complex thing like getting data from raw data to serving in a functional layers that kind of identifies very clearly what data needs to, what is the data flow needs to be in order for the machine learning system to work. And again, we leave the details to you and export the repo together. So the key takeaways from our experience and from what we're kind of trying to evangelize is that you can run terabyte scale workload without basically running any infrastructure. That is done through a wise combination of open source tool or PaaS system like Snowflake that kind of abstracts away all the infrastructure for you. Not all tools have the same importance, as in if you follow the data flow from ingestion to serving, you kind of reasonably find out that some tools can kind of be swapped out with other tools very quickly. Other tools have a more fundamental part in the pipeline. The general rule of thumb is that what handles computation, in our case, Snowflake and Metaflow, is much harder to replace than what handles, experiment tracking. What we propose is extensible and flexible. Of course, we have a working example recommender system. It works in a batch fashion, but most of machine learning workload can somehow be recast as the simple pipeline that we present. And the value, again, is not so much showing this particular open source tool versus the other one, but in showing you end-to-end, demystifying through working code, what is the complexity of going end-to-end from data to prediction. And finally, and that kind of comes from our experience, before Coveo, I was the founder of a startup in San Francisco that was acquired by Coveo, is a message of hope for people that are thinking of building an ML company today and competing with companies which are way, way bigger. Thanks to a growing ecosystem of incredible tools, it's absolutely certain that today small teams can do great things in AI thanks to this ecosystem of tools, which was not exactly obvious, 4 years ago when I built my first company, and surely wasn't obvious, 6, 8, or 10 years ago. So today is actually incredible time to be part of, this community, and is a very, very good time for people that all scale, in particular the reasonable scale, to start building, cutting edge ML tools. Thanks so much for listening.
Okay. Thank you, Jacopo. We have some questions coming from online. If there are also questions from the audience, please get closer to the microphone. So the first question is, how does the architecture deal with real-time recommendations in e-commerce settings? Do you perform incremental model training?
No, the architecture we present is for batch training. So you train offline based on what you have. And that goes again towards the reasonable scale point that we made. The vast majority of companies outside of the usual 5 are still not able to figure out this. So when we started with, what is the most basic thing that provides value? And that's, batch training and then online inference. And then, of course, we look forward to a world when, we can go to online training and online inference in some way.
Okay. I will ask one quick question because we're running out of time. I've seen that in today's presentation, you have focused on session-based recommendation, which are clearly maybe the focus of your company. And I was envisioning if you were thinking of presenting the same framework also for other recommendation tasks.
Absolutely. Actually, our company does other things as well, like standard, people who bought this, but like we do a lot of recommendation. We choose the session-based one because it comes from a recent paper that we published with a transformer architecture that is, again, is not the hardest one there is, but it's much harder than an entry-level architecture. And we wanted to show that without deploying any infrastructure, you can run transformers very seamlessly. But the pipeline can be adapted to any sorts of recommendation, much easier one or even harder one if you want.
Okay, thank you. So let's thank our speaker again.